so this lesson is going to focus on the circuit design process. When we design a circuit in an open-ended situation, it's a little bit different than designing other products because we have to troubleshoot and plan very, very carefully. So specifically, we're going to be looking at combinational logic and the best practices that go into designing a combinational logic circuit. So let's get started. Alright, so this lesson is 1.2.0, the circuit design process. So in this lesson, you will look at version number 1 of the combinational logic design process to design an AOI-based logic circuit from a given word problem. So how does the circuit design process work? Well, just like the regular design process, we have a sequence of steps that we have to follow. The first thing that we have to do is look at our word problem. We first have to identify and define the requirement specifications. This includes the inputs and the outputs. And here's a helpful hint. Sometimes it's helpful to create a table that defines what it means for a specification to be high or low, similar to a truth table. After we've analyzed the word problem, we then have to identify our circuit types. So what ICs do we require and which ones are available for the design? Do we need inverters, AND gates? What are we working with? Will any part of the circuit require an analog design? That means instead of using a high or low signal, we have to control it with a variety of voltage. Is there combinational or sequential logic required? Do we need a clock signal? Do we have the necessary data sheets? And do we have the necessary pin diagrams? After we've gathered all of that information, we then need to design our truth table for our combinational logic section, and then complete any hand calculations and sketches of our initial circuit. We would then move into multisim, where we create a simulation, and then after we have a functioning simulation, we take it to the breadboard and test it as a functional circuit. When we're in the circuit design process, we have a few best practices that we should follow. First is that we need to prototype and test the circuit incrementally. If we design and build the entire circuit only to find that it doesn't work properly, it's much harder to troubleshoot than if we build it in sections and make sure individual sections work as we go along. As we move through the course, you're going to be introduced to other advancements in technology in the circuit design process itself. And as you learn about these advancements, you're going to be able to make even more choices that will help you design more efficient circuits in a shorter amount of time. But for today, we're going to start with circuit design by exploring simple designs and combinational and sequential logic. So this is the version of combinational logic that we will actually be using to create our first circuit. We're going to start with the word problem, then follow it up with the truth table. We'll then write logic expressions, and then we will actually talk a little bit about Boolean algebra, and then we will then implement our logic for our circuit. Now the first time we do this, we're actually going to do it without simplification, so that way you can see the difference between a simplified and an unsimplified circuit. Now in version 2, we can actually skip a few of these steps once we learn a process called K-mapping. We're going to learn about K-mapping in a few weeks. Okay, so that was a quick one. We are going to wrap that up and move into the classroom. We are going to actually create a combinational circuit logic from an open-ended word problem in class. So I'll see you soon. Bye, guys.